Hey there! This is MathCamp321 presenting a short video on equations of circles. The equation of a circle has a special formula, and that is given in the rounded box as x minus h squared plus y minus k squared is equal to r squared, where h and k is the center and r is the radius. So we can extract the center of a circle by looking at this number here and this number here and taking the square root of this number to get the radius. So let's dive into our first example. For questions 1 through 4, identify the center and the radius and then sketch each circle. Well, just so you're clear, numbers 3 and 4 are on the next page, or on the next slide. So let's start with number 1. First of all, when you look at number 1, I'd just like you to compare number 1 with this template that's in the rounded box that we just looked at. And they look really, really similar. If I look at the first number after the x, we see a 5. And if we look at the number after the y, we see a 1. And then if we take the square root of this number here, we get the radius. So for this particular problem, the center is 5, 1, and the radius is going to be the square root of this number, or 2. Now that we've established the center and the radius, which are really important aspects of any circle, we're going to go ahead and draw the circle. So I'm going to plot the point 5, 1. Starting at the origin, I'm going to go over 1, 2, 3, 4, 5 units, and then up 1 unit. Now the radius of the circle is 2. So I'm going to go up 2 units, down 2 units, left and right 2 units. So up 2, down 2, left 2, and right 2. And now I'm going to draw the circle as best I can. Now some days are good days and other days are bad days. Let's see what happens here when I try to draw this circle. Alright, well that was not horrendous, but it was not amazing either, but that is the circle. Now, when you draw a circle, you really should label the center, and this center is at 5, 1, and the radius is 2, so maybe I'll denote that by just projecting a line from the center over to the circle, and I'll call that 2. Okay, now there's a little question below the graph here, and it says, in which quadrant is the center? And the center of this circle is located in quadrant 1. Alright, let's try another one. Let's go to number 2. It says x squared plus y squared is equal to 16. Now believe it or not, this is actually a simpler case than number 1. It looks similar to our template in the rounded box above, but it's missing the minus h and the minus k situation. So I'm going to write this in another way, which I think might make a lot more sense. I'm going to write it in the following way. X minus 0 squared plus y minus 0 squared is equal to 16. Now, x minus 0 is the same as just x, and y minus 0 is the same as just y. So you may ask, well, why did you bother to rewrite it then? Well, that's because writing it over this way, it makes it look exactly like this template in the rounded box. And then we can focus our attention on this number here and this number here, and we can take the square root of this number to get the radius. So having done that, what do you think the center is? I'll give you 5 seconds to think about it. Okay, great. The center is 0, 0. And if this is the number at the end, what do you think the radius is? Keep in mind that at the end we have r squared. We have the radius squared. So to get the actual radius, you need to take the square root, which means that our radius is, and I'll give you 3 seconds. Okay, great. The radius is 4. Okay, I'm going to plot the center and try to draw the best circle that I can. The center is at 0, 0, and from that center point, I'm going to go up, down, left, and right 4 units. All right, let me draw the circle. Let's see what kind of circle I can do. The first one I get, on a scale of 1 to 10, that first circle in question 1, I give it a 6. And that might even be generous. Let's see what happens here. I'm not sure if that's a whole lot better. I'm going to give it a, that might even be worse actually. I'm going to give it a 5.5. But we all know what I meant. It's supposed to be a circle, and the center is at 0, 0, and the radius is 4. And to show that, maybe I'll just highlight this little segment right here, and I'll call that 4. And now there's this question right below. What special name is given to the point that is the location of the center? Now the center is 0, 0, and that's also known as the origin. Okay, so on this slide we introduce the idea of HK form of a circle. It is this template that immediately reveals to us what the center of the circle is and what the radius of the circle is. And these are two of the probably the most important aspects of a circle. And if once you know the center and the radius, you're able to fairly quickly sketch a circle. So yeah, this is slide 1. Let's move on to slide 2. Okay guys, here we are on slide 2 of HK form of a circle, or equations of circles. And I think these last two problems are going to go much quicker than the first two now that we have a basic idea of what we're doing. So number 3, they give us the equation x squared plus y plus 3 quantity squared is equal to 1. Now this doesn't look exactly like the template on the other slide. In fact, I want to start right now by just refreshing what that template was. So I'm going to write this up on the upper left. I believe it was x minus h quantity squared plus y minus k quantity squared equals r squared. Now when I look at number 3, what strikes me is the second term, the y term. The y term has a plus in it. And up here, there's a minus. So I'm a little bit confused. But there's a way out of this mess. And that is to think of positive 3 as minus a negative 3. So I'm going to go ahead and rewrite this as x squared plus y minus negative 3, keeping in mind that minus and negative is really the same as plus 3, equals 1. Now when we do this, we get our final number, which represents the radius squared. This is the y coordinate of the center. And then we saw this in the first problem. When there's just an x squared or a y squared, that means the same as x minus 0 squared. So the x coordinate of the center is going to be 0. So our center is going to be 0, negative 3. And the radius is going to be the square root of this number, which is just going to be 1. So I'm going to go ahead and plot the center at 0, negative 3. And I'm going to go 1 unit to the left, to the right, up, and down. And now I'm going to draw as best I can this circle. Let's see how this goes. Please don't laugh if it's awful. I think that might be the best of the 3 so far. It's still a little bit smushed looking, but I think it's the best. So anyway, I'm going to label the center, which is 0, negative 3. And now I'm going to just draw a line segment which will represent the radius, and that radius is 1. Okay, and there's a little special question under the graph, and that says, this circle exhibits symmetry over which axis? Now the word symmetry, whenever I think of the word symmetry, I think of a fold. If we were to fold over one of the two axes, the x-axis or the y-axis, each side of the fold will line up. So I think if I were to fold along the y-axis, the left and right sides of the circle would line up. So I think this exhibits symmetry over the y-axis. Okay, let's go to our last example, number 4. X plus 2 quantity squared plus y plus 3 quantity squared equals 9. Now again, we've got that same issue that in the template we see a minus in between the x and the h, and we see a minus in between the y and the k, and here there are pluses. But I showed you in number 3 how we can work around that. A positive 2 can be thought of as minus a negative 2, and positive 3 can be thought of as minus a negative 3. Now it looks exactly like the template, so everyone should be very happy. So this reveals to us the x coordinate of the center. This reveals to us the y coordinate of the center. And then we take the square root of this number to get the radius. So what this tells me is that the center is -2, -3, and that the radius is 3. So I'm going to go ahead and plot -2, -3. And now I'm going to go up, down, left, and right 3 units. Alright, and we have our final chance here of drawing the most amazing circle yet. Let's see what happens. That also was not too bad. That's okay. I think I'm going to give this one a 7. And the one before that I'll give it a 6.5. So I'm showing improvement, I think. So I'm going to go ahead and label the center. This was -2, -3. And I'll just draw this line segment right here, which represents the radius, and we know the radius is 3. Cool. Now, this one has a special question underneath it, and it says, this circle is tangent to which axis? Now, the word tangent means touching at one point. So when I look at this circle, and I look at the circle in relation to the 2 axes, and maybe I could even go ahead and bold those axes a little bit more. I just bolded the y-axis, and now I'm going to bold the x-axis. Which axis is the red circle just touching the black circle at one point? Is it the y-axis or is it the x-axis? Well, I think it's the x-axis. If we look at the very top of the circle, right here, the red circle is touching the black x-axis just at one point, and that's at the point -2, 0. And that would be called the point of tangency. If we look at the red circle in relation to the y-axis, it is going through the y-axis twice. And by definition, the word tangent means touching at one point. So that does not fulfill the definition for tangent. So in these 2 slides, we've covered HK form of a circle. It's a very, very important form because if a circle is written in that form, you can readily tell the center and the radius, which are probably the 2 most critical aspects of any circle.